All right, here are solutions for perfect problem 5 for Math 95. We're given, this thing, 900,000 x to the ninth y to the sixth, and then some other things, 7,290 x to the ninth y to the sixth. And basically asked to simplify that thing, if it's the square root of it, the cubed root of it, or the fourth root of it. So I even wrote up here a little hint on how to get started on these. I think it'll help to figure out the prime factorizations of these numbers. So let's do that first. We can first find the prime factorization of 900,000 by finding any two numbers that you can multiply together to get 900,000. The two that come to mind for me are 9 and 100,000. And then 9 is 3 times 3. And 100,000, let's see, that's 5 zeros. So it's 10 times 10 times 10 times 10 times 10, 5 of them. And these 3's are prime numbers. I can't go any further, but each of these 10's is 2 times 5. Oh, kind of hard to see what arrow's going where. This 10 gets this 2 and this 5, and this 10 gets this 2 and this 5. Anyways, the point that I'm trying to make here is 900,000 can be expressed as 2 times 2 times 2 times 2 times 2. Looks like 5 of them, so 2 to the 5th power, times 3, so 3 squared, times 5, and we got 5 of those also, so 5 to the 5th. So this is what's called the prime factorization of 900,000. And we do that same thing for 7,290. Two numbers that multiply together, I guess one way you get there is 729 and 10. 10 is 2 times 5. 729 is a little bit trickier. Let's see, if you add up 7 plus 2 plus 9, you get 18. And if you add up 1 and 8 from 18, you get 9. So what that tells us is that this number, 729, is divisible by 9. Kind of a cool little trick that works there. So it's 9 times something. The question is what? I think 81 is the number that'll... 9 times 81 gets you 729. Because 9 times 1 is 9, and 9 times 8 is 72. So 720. Anyways, 9 is 3 times 3. 81 is 9 times 9, which is 3 times 3. And what we get is that 7,290 has a prime factorization of 2 squared. This one, oh no, just 2. Just 2, only 1, 2. And then 1, 2, 3, 4, 5, 6 3's. And then 1, 5. So now that we have all these prime factorizations, we kind of can begin the problem. What you'll see is it's actually relatively easy once you get these prime factorizations down. So for part A, what we want to do is find the square root of this thing, 900,000 x to the ninth y to the sixth. And the way I do this is instead of 900,000, I know that that's equal to, I just found its prime factorization, 2 to the 5th times 3 squared times 5 to the 5th. And then I still got my x to the ninth and my y to the 6th. And to simplify this, what I do is I break this into two radicals, the product of two radicals. Sometimes I call them the good one and the bad one. And for the good one, I put in anything that's a perfect square. So what I'm saying is I have 5 of these 2's all being multiplied together. 2 times 2 times 2 times 2 times 2. 4 of them would be a perfect square. 2 times 2 and 2 times 2. So I can put 2 to the 4th over here, and then my remaining 2 over here. Good. Bad. Similarly, 3 squared, that's a perfect square. I can put both of my 3's over here. 5 to the 5th, I can only put 4 of them over here to have a perfect square, which means I'm left with 1 over here. X to the ninth, I could put 8 of them over here to have a perfect square. I'd be left with 1 over here. And y to the 6th, I could put 6 of them over here. I'd have none left over here. So what I get is everything in here should be a perfect square. I should be able to cancel out the square root and the exponents. The square root of 2 to the 4th is 2 squared. The square root of 3 squared is just 3. The square root of 5 to the 4th is 5 squared. The square root of x to the 8th is x to the 4th. And the square root of y to the 6th is y cubed. So this simplifies to this. I can actually take it one step further here. 2 times 2 is 4. 4 times 3 is 12. 12 times 25. Okay, that was a bad way to go about this. How about 2 times 5 is 10. And the other 2 times the other 5 is 10 more. So that gives me 100. Times 3 gives me 300. So if you multiply those all together, you get 300 x to the 4th y cubed times the square root of 10x. And so a simplifies to this guy. And I can do something similar for the rest of these guys. For b, the exact same idea, except now it's the cubed root up here. So it's the cubed root of 2 to the 5th times 3 squared times 5 to the 5th times x to the 9th times y to the 6th. And I'm going to again break that up into 2 different cubed roots. I guess I should say I'm again break it up into 2 different roots. This time they're cubed roots. But now they have to be perfect cubes to be over here on the good side. Maybe I'll even label these good, bad. So whereas up here I just needed pairs of them to be on the good side, now I need triplets of them. I need 3 of a kind to be on the good side because they have to be perfect cubes. So 2 to the 5th, I could put 3 of them over here, but then I'm still left with 2 over here on the bad side. 3 squared, there's nothing good out of that. I'm just left with 3 squared over here. 5 to the 5th, I could put 5 cubed over here, and I'm left with 5 squared over here. X to the 9th, that works out well. I can put them all over here. Y to the 6th, I can put them all over here because these are both perfect cubes. So what this, maybe I'll try to not take up extra lines. What this ends up being is the cubed root of 2 cubed is just 2. The cubed root of 5 cubed is just 5. The cubed root of x to the 9th is x cubed. The cubed root of y to the 6th is y squared. And then left under the cubed root sign I have 2 squared, which is 4. Well, let's see. I have to multiply this number out. Well, I'll do that in the next step. No, I'll do that in this step. 2 times 5 is 10. The other 2 times the other 5 gives me 100. 3 times 3 is 9. So 9 times 100 is 900. Another way I could write this is it's 10x cubed y squared times the cubed root of 900. All right, continuing, part C. Same idea. It's probably a little bit overkill, but let's do it again. Now it's the 4th root, just to make sure you're really sure you got the idea of how these work. I got 2 to the 5th times 3 squared times 5 to the 5th, x to the 9th, y to the 6th. So I'm going to again break it up into 2 radicals. However, this time instead of cubed roots, they're 4th roots. And to be on the good side, you have to be quadruplets. You have to be groups of 4. We had groups of 2 up here, groups of 3 down here. We need groups of 4 down here. So 2 to the 5th, I can take 4 of those guys and put them over here, and I'm left with 1 over here. 3 squared, nothing I can do with that. Stuck on the bad side. 5 to the 5th, put 4 of them over here, and I'm left with 1 over here. X to the 9th, put 8 of them over here. I'm left with 1 over here. Y to the 6th, I could put 4 of them over here, and I'm left with 2 over here. So let's see, the 4th root of 2 to the 4th is just 2. 4th root of 5 to the 4th is 5. The 4th root of x to the 8th is x squared. The 4th root of y to the 4th is just y. And then under my cubed root here, I got 2 times 5 is 10. Times 3 squared, which is 9, so that gives me 90 xy squared, which I could write as 10 x squared y times the cubed root, or the 4th root of 90 xy squared. Whew, okay, that probably is enough that I should be done with this problem, but I'm not because I made 6 parts to this, which wasn't a great idea, but too late now. I'm going to do D, E, and F. I'm going to do them in the exact same way, maybe even a little quicker. For D, I want the square root of 7,290 x to the 9th, y to the 6th. And 7,290 is 2 times 3 to the 6th times 5. So I'm going to break that up into 2 square roots. Just 1, 2, so that has to go on the bad side. I guess I should keep writing these. This is the bad side, this is the good side. This was the good side. This is the bad side. 3 to the 6th, that works out nicely. We put them all over here on the good side. Just have 1 5. Can't pair that up, so it goes here on the bad side. X to the 9th, I can put 8 of them over here, and I'm left with 1 over here. Y to the 6th, I can put them all over here. And so what I get is the square root of 3 to the 6th is 3 cubed. The square root of x to the 8th is x to the 4th. And the square root of y to the 6th is y cubed. And in the bad radical, I have 2 times 5 times x, in other words, 10x. And 3 cubed is 27, so I could write this as 27 x to the 4th, yeah, okay. X to the 4th, y cubed. I was afraid I made a mistake, but I don't think I did. Bam, done with part D. 2 more, E and F. They're going to follow D a lot, except now instead of being square roots, they're going to be cubed roots. So the cubed root of 2 times 3 to the 6th times 5 times x to the 9th times y to the 6th. You can break that up as 2 different cubed roots, a good one and a bad one. And let's see, 2, there's just one of them, got to put it over here. 3 to the 6th, I can think about that as 2 different groups of 3s, so I can put them all over here. 5 doesn't have triplets, so they go over here. X to the 9th is x, all goes on the good side, and y to the 6th all goes on the good side. And so what I get is the cubed root of 3 to the 6th is 3 squared. The cubed root of x to the 9th is x cubed. The cubed root of y to the 6th is y squared. And I want to multiply that by the cubed root of 2 times 5, which is 10. So what I get for my final answer is 3 squared is 9, x cubed y squared times the cubed root of 10. Finally, last one here, part F. Exact same idea. Again, this is probably a little overkill. Sorry for making you guys do so many of these. The difference here is now it's the 4th root. So I'm going to break that up into 2 different 4th roots. Over here will be my good one. And over here will be my bad one. And to be in my good one, you have to be in groups of 4. So I just have 1, 2. Nothing I can do with that. Goes on the bad side. I have 6 of these 3s. So I can put 4 of them over here. And then I'm left with 2 of them over here. Just 1, 5. It's going to be on the bad side. X to the 9th. Put 8 of them over here. And then I'm left with 1 over here. And y to the 6th. I can put 4 of them over here. Then I'm left with 2 over here. And so the 4th root of 3 to the 4th is just 3. The 4th root of x to the 8th is x squared. And the 4th root of y to the 4th is y. And I want to multiply that by the 4th root of 2 times 5 is 10. Times 3 squared, which is 9. So 9 times 10 is 90. X, y squared. Whew! Alright, that's finally the end of this, assuming I didn't make any mistakes. So that's the end of the video.